Hi guys. Quite a quiet talk. Don't know how many if we're expecting any more, but I'll jump in. So my name's Joe Devine. So I work for Apollo GraphQL, and going to talk about how ChatGPT can help us build a supergraph. So just before I jump in, how familiar are you guys with GraphQL? Fairly, a little bit, yeah? No, not at all. Okay. Have you heard about federation? A little bit, maybe not, and then managed federation, probably not. Okay, cool. So just to rewind then, so I get a little bit of context to GraphQL, what a supergraph is, and where Apollo sits as well. So why this is relevant, why I think it's quite exciting, what ChatGPT can allow us to do. So I'll rewind a little bit. So these architectures might look familiar. So as a brief history, as we started to move into microservices, and I'm assuming you guys are probably familiar with microservice architecture. Yeah. So as much as that gave benefits, so it gives you autonomy, you've got speed of delivery, there's not a bottleneck of deployments. You do have a huge number of APIs that you have to manage, and that can become a bit of an issue, which led us to the BFF pattern, which see in a lot of different places. As you start to have different journeys, so you have a website or you have a mobile device, often it's easier to have some kind of backend service that you talk directly to, and that does your business logic and your aggregation and manages those REST APIs for you. But again, issues here because there's divergence. How do you manage this? There's governance can be different. There can be tech debt that grows from there. So enter here GraphQL. So I won't go too much through kind of the intricacies, but essentially the real benefit of GraphQL is that the client can ask specifically for the data that it needs. So the idea there being that it's a graphical query language for your data. It's not a different protocol. So GraphQL is HTTP request. But what's nice is the client can say, right, say it's an e-commerce site, I want products and I want reviews. Doesn't really matter that products comes from a products service and then reviews comes from another one. And maybe historically you'd have to do an API call for your products, get a primary key back, then get all your reviews, do some business logic. GraphQL can just say, right, to one endpoint, I want products and I want reviews, and your GraphQL service can bring that data back. So it solves for overfetching and underfetching. So overfetching being the case where a REST API will just give you a data object. GraphQL says, I just want this data. And the benefits of that is that if there's a service that's providing a REST API, maybe it's going off and getting data that the client doesn't need. So there's unnecessary network calls, overhead, and unnecessary business logic on the client as well, because maybe it's got to loop through the object, pull out some data, do some data transformation, that kind of thing. So that's like super fast, high level kind of benefits of GraphQL. But that becomes a new bottleneck. So I've had this myself. So my background is I've been working as a solution architect for Apollo for about a year now. Prior to that, I was an engineer and an architect for about 10 years and had the joy of being on the other side of the fence, implementing GraphQL in a number of different banks and large organizations. And one of the first places I worked, we had this problem. So we were using it to solving the overfetching problem. But you end up with another monolith. You have a new bottleneck. You have one service that you have to manage. You've got to manage your endpoints and your resolvers. So you start to break it out. So you end up with this system again, which looks very familiar to the BFF problem, where you've got multiple different graphs, you've got divergence. How do you govern it? How do you have best practice? So the solution, or where we've come to so far, see, ever evolving landscape, is something called federation and federated graphs. And what's really nice about that is that you can break down your individual GraphQL services into what we refer to as subgraphs. And then through a mechanism of federation, it's a set of rules that allows them to be composed into a single, what we refer to as supergraph. And that's done automatically through a process of composition. And then the client and the customers can just consume one supergraph, one SDL. They don't have to care about where these subgraphs come from. They don't care about which individual teams updated which parts of the graph. They've just got a completely holistic view of their data. But that allows that to be federated across different subgraphs. So another way of looking at that, a diagram here. So there's probably a nicer way that we could represent this, but essentially what we've got here is all these different journeys, your mobile app, your web, all coming to a single entry point on Router. So Apollo offers a binary runtime that runs your supergraph. Here is your SDL, so like the full schema for your full supergraph that was generated through composition. And that's made up from the GraphQL schemas of each of these different subgraphs. So in that case of products and reviews again, it could be that, say on our web app, we want to have all our list of products and all the list of reviews for those products. Web app historically with a REST API would have to go get all my products back. Then I will have a primary key for that. Then I need to go and make a request for my reviews. Then I need to do mapping, and that would often sit in the client. Now, Router knows exactly how to do that. It can go off to product, get the query, can go off to, and it does all that aggregation and hides it from the client. So that's a whistle-stop tour of the the architecture and some of the benefits and the reasons why we might want to generate a supergraph. And I've got another couple of slides just to show how Apollo fits into that. So how many of you guys have heard of Apollo before? Have you heard of Apollo Graph? Yeah, awesome. Okay, so a quick overview of how we fit into GraphQL, because you can do GraphQL without Apollo. GraphQL is an open source spec. You can build it. It's just HTTP calls. But as you start to do that, there becomes challenges and implementation things that can become a bit of a pain. So this is an overview. Just down here, we've got what would be your runtime. So you've got your different journeys. Again, you could build just a HTTP call that's going to post your GraphQL query, but actually Apollo offers a number of different clients for iOS or Android or web, and that can handle things like caching, handling your queries, that kind of stuff that you'd have to do manually otherwise. Then that can talk to Router. So Apollo offers the Router that you can use. You can use the Router for free, or there's paid for version. It's got a bunch of other features. And then what that does is that then talks to your subgraph servers. So that's where the magic happens and the resolver of your actual data. And all that requires is that the router is talking to a federation compliant subgraph framework. And there's open source frameworks for that. As long as it complies to the federation spec, it can be federated to. And they can be any number of languages as well. It could be TypeScript, could be Python, could be whatever it is, Golang, whatever you want to write that in. As long as the schema and the server is federation compliant, that will work. So that's your runtime down the bottom here, which is all great, but there become challenges with that in terms of managing it. So Apollo offers a management plane as well. So when you're actually building them, when you're running your composition checks, so as you split out within an organization, you might have a thing where two different teams are trying to expose the same data type. So they define a certain type because they both need access to it. Well, if they both expose a top level query, then maybe the router wouldn't be able to know which way to go to resolve that data. So composition check would catch that. So you can't have those breaking changes. Also, it can do things like, say you go to remove a field from your schema, it understands what's been used historically because it's got tracing. It can say, oh, actually, iOS client, blah, 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 it has been using this within 28 days, block those. So that kind of stuff is really beneficial. Registry, just for managing your schema and insights. And yes, there's some other benefits there as well. And just another slide showing the same kind of thing. So that was a super quick whistle-stop tour of where Apollo sits. So hopefully, as we get into what ChatGPT can do for us now in the generation of supergraph schemas, this is why it's interesting to us, and I think why it's exciting for us, the kind of possibilities of what it can do. Cool. All right. So that's Apollo and that's supergraphs. But what is ChatGPT? I'm assuming everyone here has probably heard of ChatGPT. You've heard of it yet? So it's been, so lots of talk of it. It's been in the news a lot, especially in the last year. But I'm going to go through. I'm not an AI engineer, so the very low level tech. But I'm going to talk through the concepts and how it works, because that will allow us to understand how we can use it and what that means for us and how we can interact with it. So super high level. Little graphic of us asking ChatGPT what it is, but you can see ChatGPT is a chatbot that talks to a generative pre-trained transformer model, language model. As you can see it telling us here. That's what the GPT stands for as well. So yeah, so it's a chatbot interface on top of a large language model. But what does that mean? What is a language model? So a language model is something that takes text input and uses that to predict what the next word will be, or what the next thing in the sequence is going to be. So examples of this could be, if you guys use Google Mail, as you start to type your email, you'll often see that it's starting to predict what you think is at the end. That's based on previous input. So that's a language model. Same as when you type on your phone as well. So as you're typing a text, you start to see the words pop up at the top. Based on your historical text, it's using that to predict what your next text is going to be. So that's a language model. But how do they work at a high level? How do these work, especially for ChatGPT, which is what we're talking about? So the way that they interpret these and build up is we first have to turn the input into something that the language models can understand. And the way we do that, so we take, is a very, very simplified example. I'm going to have an input here of I go to work by car. Now what we do is we turn them into tokens. Now in practice, with the vocabulary that things like ChatGPT have, it's actually a combination of words and partial words. But for this example, you can see we break them down into individual tokens. As these models are being trained, so when they're initially being built and trained, they go through each of these words, and with huge amounts of data input, they analyze what words often come near and are in proximity to these given words. So it starts to build up an understanding of where the word, so for in this example, where the word work exists, what type of words often appear either side. Because what we're trying to produce is a distribution, a probabilistic distribution of what the likely next word is based on the input. So this starts to build up a bit of a picture of, you know, what words often turn up next to work and a couple of examples of words that don't. And what's nice about this is this then gets stored in a vector, builds up a profile of what is likely to turn up next to a given word. And it's called this a word embedding. And as this happens for the full vocabulary of the language model, what's really powerful is you start to see that these word embeddings are very similar for words that have similar semantic meaning. So it's actually a way of quantifying the linguistic meaning of the words. So you can see here we've got sea and ocean, not completely the same, because you wouldn't say things like plenty more fish in the ocean, or, you know, there'd be certain inputs that would be different. But ultimately you start to build up a picture of the meaning of the words. Another graphic I was possibly going to add was, if you imagine, obviously not plotting it with this many dimensions, but on like a two-dimensional plane, as you start to plot these words, you'd see groups. So you might see that table would be close to chair, or, you know, happy close to sad. So you start to get some kind of groups of meaning based on the similarity in the values of these vectors. So that's how we get to understand profiling of these words, and that builds up the vocabulary, and this gets trained over time. So these models get updated as it learns. So what's powerful about that? So that's all really good, and that gives it a good basing to have some kind of understanding of these words. But what's really powerful about them is their transformers, and particularly attention. So this is why really it's exploded over the last kind of year or so, is because these algorithms have really come on a long way. And what's important about attention is, take that previous word about I go to work by car. A very simplistic language model would take each individual word and try and predict the next word off that given word. So a sequential step through the words. But if that, in that case, I go to work by, that means you'd only be using the word by to predict the next word. And there's not much information in that word to be able to predict that next word. So what we do is attention looks at the neighboring words, and it's quite a deep subject, and there's different ways that different models do it. But essentially what it does is each one of these words has got its word embedding. So it's got that vector of understanding of what each of these words mean. But it does an aggregation of the input. So it gets an overall semantic meaning of this word. And there's different ways it's done on position and difference between different words. But ultimately it builds up a vector of the overall input to give a deeper understanding of that text input. Another way to think about it, and one example of why this is important, is situations like this. So we've got a relatively long sentence of 11 words of the animal didn't cross the road because it was too scared. Now for us, it's really obvious that it, in this case, is animal, because we've got the context. We've had lots of inputs. We understand that is the context. This is how this would be phrased. Whereas just by changing a single word at the end, again, instantly, we now know it means the road. This wouldn't make sense that the animal didn't cross because the animal itself was more dangerous. So it seems obvious to us, but that's only because of the number of inputs and context and the data that we've read before that wouldn't make sense the other way around. So it's a simplified example, but it's that kind of thing that builds up an overview of what these things mean. So that was a super high level. Bring us all the way forward to today. ChatGPT, Llama 2 by Meta, Bard by Google, huge number of parameters. The transformer models become very complex now, and a huge number of parameters, billions of input words, billions of parameters, and have now got to a point where we're getting that human-like output. So brings us to the big question: are they smart? Are we going to get taken over? This is the interesting one. Well, there's a couple of issues with these. The first one is cutoff date, and this is very relevant for us. So, as Apollo, and we're looking at how we're going to generate supergraphs, cutoff dates is really important because ChatGPT 3.5 and 4, which are the two models that you can talk to today, they have a cutoff date of 2021. And for us, Federation 2 came out at the start of 2022. So ChatGPT 3.5 doesn't have any idea about Federation 2. So if you wanted to talk to it about how to build a Federation 2 compliant schema, it's got none of that context. The cutoff date is a really important one. And the reason for that is it takes a huge amount of time to train these models, huge amounts of data. So that's a really critical one. I think new future versions are looking to tackle that over time, but it's a big one to consider today. And another really important one is hallucinations. Now, I don't know if anyone heard the press release for Google Bard when that came out. So there was a very public hallucination where it made up what the Webb telescope was the first one to get a picture of a planet. And actually, that wasn't true. But the reason for this, so hallucination is where a language model will just essentially just make something up, just hallucinates. It will say something, whether it's true or not, it's going to say something, which can be a problem. And there's a few reasons for this. Either poor data input. I mean, one of the things that could be an input for this would be like all of Wikipedia, which we know isn't necessarily true. So based on historical how the data has been inputted, could be a problem. The way in which text is generated, so there's different ways of searching for the response. It's like greedy or beam. Like what that can do is that could have a higher probability to more generic words and a lower probability to more specific words, and that might send it to the wrong conclusions. Or we didn't provide enough context. So it's not got enough words to infer what the meaning is. So very contrived example could be, can animals talk? And then the answer would be obviously no. But if what I meant was, can animals talk in Disney films? Then the answer is, of course, yes. But I needed to tell it that. It can't infer. So context is a big one, and more input is a really big thing here. So yeah, just between those two versions, so I mentioned, so there's ChatGPT 3.5 and GPT-4 that are available at the moment. GPT-4 trained on a much bigger data set, so it's more accurate, more detailed. But constraints are, GPT-4 is a paid service, so 3.5 is the only one that's freely available at the moment. But also, GPT-4, as a result, is a lot slower. And I'll show you that in a minute. So GPT 3.5 is a lot quicker to generate responses. Demo time. Cool. How are we for? Okay, cool. All right. Cool. So actually, before I jump into it, for this demo, I'm going to ask ChatGPT to write a GraphQL schema for an application that's going to allow users to plan trips for conferences. Now, a couple of things on this before I do this. This is very simple. If I was an engineer and I got that as a brief, I'd want to know what type of conference. Is there online stuff? Do I need to know about the rooms? Do I need its trips? Do I need to know about travel integrations? So we've not given it any of that context. So it's very simple. So there's that to bear in mind. And also, large language models are not deterministic. And that means that I've run this before, but we're definitely going to get a different answer now because every time you ask it, it's not necessarily the same answer. Okay, let's jump in. So here's ChatGPT. So I've got, 3.5 and 4 at the top here. Can you see this okay? Is that quite small? Okay. I'm going to write a GraphQL schema for an application that will allow users to plan trips for conferences. This is to 3.5. So we can see here, it's outputting a schema for us straight off the bat, which is a really great start. And actually looks like it's done quite a nice one as well. It's doing some really quite nice things using like date scalars. It's not doing any pagination, for example. There's some quite heavy types here, some discrepancies between the queries. So some heavy mutations here as well that might be ambiguous to a client, some nullable inputs here. So not necessarily best practices, things we'd probably pull up on if this was a schema that you designed, but generating a schema, which is a great start. So could we improve it? So we can say, I don't know, use relay pagination, for example. And it's going to take back, and because it's in the context, we can see here, so it's added a trip connection here. It's going to add an edge for us, probably, hopefully. Yeah, cool. So yeah, there we go. Trip connection at the bottom there as well. So you can see how we can kind of iterate on this within the context, which is really great. But there is a limit to this, because in your conversations, you can't just have an endless conversation with ChatGPT. There is a limit to your context. And what's happening is, the reason we can say, things like add relay pagination. I didn't give any more context in this message, because the whole message is sent as context to the API once we make an update to this. So you can hit a limit there in your conversation. And to go through and have to manually input all the best practices isn't going to be very sustainable. Plus, the size of the schema is going to be characters to take up your context as well. So as that grows, how much flexibility you've got is going to be an issue. But a good start, just going to show you as well. So we can also look at what ChatGPT 4 will do. So if I ask here, do the same thing. See, quite a bit slower as well, but quite a bit more detailed as well in terms of trip input there. Location, queries look a little bit more sensibly put together. But again, no pagination, maybe some discrepancy in the names though. Some nullability issues there on that input type that might leave it ambiguous to an end user. So things that we'd want to fix here, so not necessarily best practices, but better. So just to demonstrate the difference there between 3 and 4. Cool. So that was a quick demo of what ChatGPT can do as it is, which is cool. So we can, as it stands, we can go on and we can use these tools to help schema design. And we can iterate. So the interface allows us to iterate on the schema that it gives us and come back to it and start to slowly improve it, which is great. But they don't really know much about GraphQL. For this purpose of this talk, that's what we're trying to do. How can ChatGPT help us build sensible supergraphs and help with that design? So how can we make them better? Well, it's a couple of things. One is system prompts. So in the way that we just iterated on those inputs and inputted more and more kind of best practices to it, system prompts are additional prompts that get added to the request to the API. So because what gets sent is a list of inputs, you can add basically an additional number of inputs that get sent with that to have a more detailed response. So system prompts is powerful, and I'll show you that in a moment. But even better than that is fine-tuning. So OpenAI offers the ability to tune, at the moment, a couple of ChatGPT 3 models. So what that means is that gives you a model that you can pre-run fine-tuning training material on, that you can help tune the responses you expect from that given model. And what's great about that is that's prior to the context of your conversation with that model. So you can give it like expected responses. So and I'll show you a little demo in a second. You basically say, this is the input and these are the responses I would expect. And the way that we've done a bit of this is that you take a response, you ask it a question, you get a response, and then we're kind of fixing the answers and replying that actually this is what we would expect from this question. And over time, create a model that has got these inputs already. So that's going to improve the output. So that leads me into demo number 2. Waiting for time. Cool. So if I come here, what I've got running here is this is a local app. I've just got this running on localhost. This is a UI very similar to the UI of ChatGPT. And I've also locally got a GraphQL server that is taking the inputs of this and is talking directly to the OpenAI API. So I can ask it the same thing. I can say, write a GraphQL schema for an application. Yeah, I can show you how we can fix this. So here we can see it's just outputted the text of the input of the schema. So we can fix this with system prompts. It's as if I meant it. I didn't. So what's happening if I go to the code? I've just zoomed in. Is that okay? Can you see that okay? So I'm not going to go through the whole code base. Essentially, the bit that matters is this run completion. This is the bit that is talking to the API. So we're passing here a list of these OpenAI messages, sorry. And we've also got a little function here that just says, if we add some custom prompts, these will be our system prompts, include those with our responses. So I can come in here and I can say, be snarky and funny and use lots of emojis. Not ever going to want that, but for the sake of demo. And I'm going to ask it to write a GraphQL schema again. And you can see, without having to put that into the bot here, we've got some emojis. It's starting to, some little snarky comments in the code, and adding some more things here. Again, a bit of a contrived example of how system prompts can be added to help influence the response that you get. And again, we can extend that. We can say, use relay pagination like we did before. Helps if I can spell. Use relay pagination. Anything else we're not doing? Oh yeah, maybe use date scaler. Start to build up a list here of like things that we would want this to do. Let's do that again. Cool. So it's still being snarky, but we're using the date scaler here. So now we've got some proper date types for our start dates in conferences rather than just strings. So we've got some better type safety there. We've got some should have some pagination. Yeah, got some sensible pagination now as well. So again, another thing that we could do here is build a tool that has these system prompts of best practices. So you could expose something that helps you build even more sensible supergraphs. But as we're saying, fine tuning allows us to tune a model with these things already so that we don't have to use up our context when we're talking to it. So what we can do, remove those system prompts for now. And down here, in this part of the call, you can see this is where we're picking what model we're going to run this against. So here is our Blue Peter moment where we had one we prepared earlier. And if I refresh that and ask it again, yep. Then this is without system prompts or anything. This is hopefully going to do something relatively sensible. Cool. Yeah. So you can see here we've got some pagination, which is done because the model's been tuned, and that's not used up some sensible input types as well. This is on 3.5 as well. So this is on top of a less detailed response of 3.5. So you can see here we're starting to get some more sensible responses from a model that's now been trained that we can give it some best practices. And to go one step further, so one of the challenges with Supergraph and building out your subgraphs is domain mapping. And how are you going to break out your subgraphs? Because really the benefit of GraphQL is you want it to service your clients. It's the end user, because the query is generated by the client. The power is that the UI that you're building can say, I want this data in this format. Backend servers, you figure out the implementation, you figure out where that comes from. I just want this data like this so I can render it. So that means that you've got an opportunity to come at your schema design from the front end, as opposed to just exposing all your REST APIs. Because REST APIs are quite often are exposing all the data that's available in a sensible way, but that isn't necessarily the format that the client needs it, because it would depend on the user journey. So it can be quite difficult then to say, what are my subgraphs going to be? Because quite often wouldn't recommend a one-to-one between microservices and subgraphs. Do see it, but you miss an opportunity there for maybe, in the top context where we had like products and reviews, maybe a product subgraph needs stock and inventory and some other services and some different other things that is going to input on that. And then that could be a domain that would control that data model, for example. So in this case, so bring it back to our example of the conference, how are we going to build our subgraphs? And now what's really exciting about this is I can say to ChatGPT, and hopefully because we've fine-tuned it as well, split this graph using Apollo Federation. And here, what it's done is it's understood what I meant. It's created some subgraphs for us. We've got account service, conference service. It's broken out there. And it's going to give us an example of some different things here. And what's really exciting about this as well is, for those of you if you played around with the different Federation versions, in Federation 1, which is all that ChatGPT would know about, often when you do this kind of thing where you extend over a certain type, in Federation 1 syntax would be that you'd extend a type and give it a primary key. Federation 2 is you don't need the extend keyword anymore. So you can see here that this is understanding the inputs that we're starting to give it over Federation 2. Obviously, it's just a demo for the purposes of example, but exciting that it's starting to pick that up and it's that easy to start tuning a model that can give us best practices that have come out since GPT-3 was trained. Cool. So just to kind of recap, we didn't have time, okay? Yeah, cool. So just to kind of recap those demos, GPT-4 is slow, but usually more accurate because of a bigger data set. And GPT 3.5 is a lot faster, but needs more input. So often needs a bit more coaching to get to the same level of standard. We can keep chatting with the model to improve the schema. So the context of the conversation is kept and passed to the AI, to the API each time. We can also use system prompts, so we can add instructions to the requests that we make to the API, so we can kind of improve those responses. And we can also fine-tune models so that these are baked in. So we have a model that already understands some of these best practices already. Oh yeah, also I just thought I'd add a note to never enter anything sensitive as well, because it is worth knowing that the processing and the interpretation and the learning and training of the model takes on the inputs that are given to the model. So always conscious not to add sensitive information if you are doing your designing. Cool. So I think the big takeaway from all of that though, is that these tools are not substitutes for good schema design, but they might help you get there. And what I mean by that is that we can train these models with best practices. We can teach them what good federation looks like, good domain mapping looks like, some of the kind of GraphQL best practices. We can teach it on the spec, so it understands how to use all elements of best practice. But again, it comes down to servicing the client, and you want to build a schema that basically removes the business logic from the front end, so it can just get the data exactly as it wants. And that is going to be use case specific. You don't want to, you don't want that kind of bottom up dictatorship of how data has to get to the front end. You want to service what your UI and your user experience is going to be doing, and that's going to be completely dependent on the given user experience. So these are really good to help as a starter point, but it's never going to know what the best, it's never going to completely know your user experience, and you've got complete freedom. And because that's the beauty of GraphQL, is that you decouple the client from the backend. So you've got that ability to map that yourself. So yeah, so I think that's probably the big takeaway there. But what's next for us and what we're experimenting with? First, train it with much more data. So we want it to not be mostly right. We want to train it with a lot more to make it much more accurate, much more predictable. Other things that we could do that we're talking about is maybe we could feed our entire docs to this model. We could give it all of our documentation. So not just to design your schemas, but if you've got a question about implementation, maybe you're using the router and I want to do some header manipulation on inbound something, and you want to understand how I can interrogate claims, or then you could just talk to the bot that understands what's available up to date, and especially with future releases, because so Apollo is constantly releasing more directives and functionality to more recent versions of the Federation spec. To have those understood by the model could be part of how we release more things in the future, maybe. And we could possibly experiment with different interfaces, more integrations. It's essentially an API, so as long as we pass text input, you could integrate with other tools, other ways to talk to it. And as one final demo, there's even more possible with ChatGPT 4, which I did mention earlier. So if I was to go to this website and take a screenshot here of this, and then I go back to ChatGPT and go to ChatGPT 4, then if you can notice the difference down the bottom here, GPT-4 has the option for a picture. So here I can say, generate a GraphQL schema for this UI. So here, all I've done is I've given it a screen grab of the conference website. GPT-4, so you can only do this with GPT-4, has understood what's in this picture and is now writing us a GraphQL schema that could help service the data required for that UI. So this could open up opportunities for part of the design process, communication between front-end designers and front-end devs. This could be what you start to build from. Again, obviously this isn't from our train model because you can't train GPT-4 yet. Hopefully at the end of this year you can. But if so, it's you can see it is doing some better things. So we're using like date scaler types here for structured dates, which GPT-3 wasn't doing before. But imagining a situation where what's happening here? Oh, I might have hit the context on that. At least we get the idea anyway. So yeah, you can generate an output from images, which I think could be a really exciting way of how we communicate and work with our UI designers and part of that iterative process. And what's beautiful with this as well is because it's hard typed, you could stub this and mock this really quickly straight away. So you could have GraphQL schema, front end devs can just start building components off a hard, an easily mocked data schema, and that's completely independent of back end development. Awesome. So yeah, so that's everything from me. And yeah, if you're around over the next day or so, come and say hi at our booth upstairs.